The year is 2009. You are a structural engineer. You have designed bridges, high rises, stadiums with retractable roofs. You have spent 20 years calculating load tolerances and stress distributions and material failure points. You are standing at the base of the Great Pyramid of Giza for the first time. You brought a notebook. You were going to take measurements, cross-reference them against the published archaeological data, maybe sketch some diagrams. The notebook is in your bag. You haven't opened it. You are just standing here. Because the numbers you memorized on the plane, 2.3 million blocks, 2.5 to 15 tons each, 146 meters high, base level to within 2.1 centimeters, across 230 meters of ground. Those numbers meant something specific to you on the plane. They meant a large construction project. Standing here, they mean something else entirely. The stone in front of you comes up to your chest. One block, one of 2.3 million. The surface is rough under your hand limestone, quarried from a site 3/4 of a kilometer away, cut with copper tools, dragged here, lifted, placed, over and over and over again for 20 years. You look up. The pyramid rises above you at a 5-1-degree angle. It goes up a long time before it becomes the sky. You have a question you did not expect to have, standing here as a professional engineer who understands construction. I don't know how they did this. Not in the way that it's mysterious. In the way that the math genuinely does not close. In the way that if someone gave you this project today, 2.3 million blocks, 20 years, copper tools, no wheeled vehicles, no cranes, you would sit at your desk for a very long time before you had an answer. This video is about that answer. What we know, what the archaeology tells us, what the physics says, and what, after 4,500 years of looking at this thing, we still cannot fully explain. Close your eyes. The year is approximately 2560 BC. You are standing on the west bank of the Nile, on a limestone plateau called Giza, 7 miles outside a city that will one day be called Cairo, but currently doesn't have a name yet. The air smells of river mud and dust, and the particular dry heat of the Egyptian desert in summer. The plateau around you is flat and bleached pale. The Nile is visible to the east, brown and slow. A man is about to be buried here. His name is Khufu, second pharaoh of the 4th dynasty, son of Sneferu, who built 3 pyramids before him, including the bent pyramid at Dashur, which started steep and had to be corrected mid-construction, and the Red Pyramid, which was the first successful true pyramid in Egypt. Khufu watched his father build. He learned what worked and what didn't. Then his father died, and Khufu became the most powerful man in the known world, and he looked at the Giza Plateau and made a decision that would define what humans are capable of for the next 4.5 millennia. He was going to be buried under the largest structure ever built. The planning alone took years. Khufu's architects, we don't know their names with certainty, though one candidate is a man called Hemiunu, Khufu's vizier and nephew, whose statue survives in a museum in Hildesheim. Germany had to solve problems that had never been solved before. How do you level a plateau of 53,000 square meters to within 2 centimeters? How do you align a structure to true north to within 3/60 of a degree without a compass? How do you organize 20,000 people across a 20-year project without a single foundation error? Because the foundation had to be right. A small mistake at the bottom would become a catastrophic one at the top. They got it right. To this day, the base of the Great Pyramid is level to within 2.1 centimeters across its entire 230-meter span. We don't fully know how. Walk up to the pyramid and put your hand on the lowest course of stone. The block in front of you weighs roughly 2.5 tons. The surface is rough, cool in the early morning, despite the heat that will come later. The limestone porous enough to feel slightly gritty under your fingertips. You can see tool marks in the stone if you look closely. Copper chisel marks, 4,500 years old. One block of 2.3 million. Now, look left. The base runs 230 meters in that direction, roughly 2.5 American football fields. Same in every direction. The footprint covers 53,000 square meters of ground. The entire west end of London fits inside it. Now look up. The pyramid rises 138 meters. Today, originally 146, before the outer casing stones were stripped. Roughly a 4.8-story building. At its peak, it was the tallest thing on Earth. It held that title for 3,800 years. Not 300, not 500, 3,800 years. The Great Pyramid was the tallest structure humans had built from the moment it was finished until 1311 AD, when a cathedral spire in Lincoln, England, finally edged it out. Inside, 2.6 million cubic meters of stone. If you broke it into 1-foot cubes and laid them in a line, the line would circle the equator. The granite in the King's Chamber came from Aswan, 800 kilometers south. The blocks in that chamber weigh between 25 and 80 tons each. The ceiling uses 43 granite beams. The lightest weighs 25 tons. Someone moved 8 0-ton granite blocks, 800 kilometers, and then lifted them 43 meters into the air. With copper tools, with wooden sledges, with rope, and something else, something harder to quantify that we're still arguing about. Here is the problem at the center of everything. At the pyramid's construction pace, 20 years, 2.3 million blocks. Workers had to place one block every 2 minutes, around the clock, without stopping, for 2 decades. Every 2 minutes, day and night, for 20 years. That's the average. The lower courses with the largest blocks would have been slower. The upper courses, smaller blocks, faster. But the average works out to 1 block every 2 minutes, and every engineer who looks at that number has the same reaction. That's impossible. Except it happened. The pyramid is there. So the question isn't whether it was possible. The question is how. Feel what the project manager's problem actually was. You are Hemiunu, or someone like him. The year is 2550 BC. Khufu has been on the throne 2 years, and you need to move 2.3 million blocks in the next 18 to 20 years. Your supply chain? Limestone from the quarry at Giza itself, 750 meters from the construction site. Granite from Aswan, 800 kilometers south, transported by barge up the Nile during flood season when the water is high enough. Tura limestone for the outer casing, white polished stone that made the pyramid gleam from miles away from quarries across the river, ferried over. Your workforce, 20,000 to 30,000 workers at peak, not slaves. This matters. We know this now. The archaeology proves it. The workers' village was excavated in the 1990s by Zahi Hawass and Mark Lehner, and what they found did not look like a slave camp. It looked like a company town. Bakeries, breweries, a medical facility, evidence of high-quality food. Beef bones, fish, bread, consumed by workers whose skeletons show healed injuries, meaning they were treated when hurt rather than discarded. The workers had names for their crews. Graffiti found on pyramid blocks includes team names: Friends of Khufu, Drunkards of Menkaure. These are not the names of enslaved men with nothing to lose. These are the names of people with identity, with pride. Coercion produces minimum effort. The Great Pyramid was not built with minimum effort. Step into the workers' village. The smell hits you first: bread baking, beer fermenting, animal fat from the cooking fires, and the unwashed human smell of a settlement housing several thousand people. The village sits south of the pyramid, downwind, mud brick buildings plastered white inside, roughly 20 people per barracks. Not comfortable, not inhumane. You are a skilled stonecutter, year 15 of construction. You arrived at 22. You are 37 now, and your knees know it. 15 years of hauling stone does things to knees. The medical records found at the workers' village include evidence of survived amputations, survived brain surgery, trepanation, and broken bones that healed with proper setting. Whoever ran this project understood that their workforce was an asset. Injured workers who recovered were worth more than dead ones. You eat well. The animal bones from the Laner Hawass excavations suggest the pyramid builders consumed around 4,000 pounds of meat per day at peak construction. Not every worker every day, but enough, often enough, that the bone record is impossible to mistake. You drink beer every day. Egyptian beer at this time was thick, low alcohol, nutritious, closer to liquid bread than what we'd recognize, part of the daily ration. Your team is called something, painted or scratched, on blocks before placement so inspectors could trace quality problems back to specific crews. If a block was placed badly, the team responsible could be identified. You take that seriously. Because the other thing the archaeology tells us through the healed bones, the good food, the named crews, is that these workers had something to lose. Status within the project, an identity. Their names aren't on the finished pyramid. Their crews' names are on blocks 30 meters underground, in the dark, unread, for 4,500 years. In 2017, an international team of physicists announced they had found something inside the Great Pyramid. Not through excavation, through muon tomography, a technique that uses cosmic ray particles to image large structures the way X-rays image a chest. Muons pass through empty space differently than through solid stone. Enough measurements from enough angles, and you can see voids without touching anything. The team found a void, 30 meters long, located directly above the Grand Gallery, the 4.7-meter ascending tunnel that leads toward the King's Chamber, similar in cross-section to the Grand Gallery itself. Nobody knew it was there. Now walk into the Grand Gallery yourself. The air changes the moment you step inside, cooler than the desert outside, still carrying the faint mineral smell of stone that hasn't been touched by wind in 4,500 years. The gallery slopes upward at a 2-6-degree angle. The ceiling rises above you in 7-stepped corbels, each layer of stone projecting slightly inward, the walls narrowing as they climb until the ceiling is just over a meter wide at the top. The limestone on the walls is pale gray-white, smooth where it was polished, rough at the joints. You are walking upward. The gallery is 47 meters long. It takes 2 minutes to walk its length, sloping up toward the King's Chamber. Directly above your head, right now, is a 30-meter void. You cannot feel it. You cannot hear it. You cannot see it. There is no sign, no crack in the ceiling, no hollow sound when you tap the stone, no draft. The void is completely sealed inside the pyramid structure and has been since the day it was built. 4,500 years of visitors walked this same corridor. None of them knew. And we still don't know what it is. A construction chamber left over from the building process? A deliberate architectural space? An undiscovered room? The scans can't tell us without excavation, and excavating the pyramid is an enormously complicated proposition. So it sits there, 30 meters long, unknown. That silence above you, the silence of a sealed space that no human has entered in 45 centuries, is the most accurate representation of what it feels like to study this building. Every time you think you know what's in there, the pyramid is already holding something you haven't found yet. Herodotus, writing in the 5th century BC, 2,000 years after the pyramid was built, said 100,000 slaves built it over 10 years. Wrong on both counts. Roughly 20,000 to 30,000 paid workers over roughly 20 years based on the archaeology. But Herodotus at least had the humility of distance. We sometimes pretend we understand this building better than we do. The alignment to true north. 3/60 of a degree accuracy. Better than many modern surveys. How they achieved it without a compass actively debated. Best current theories involve astronomical observations of circumpolar stars or the sun's shadow at specific times of year. None settle. The base level, 2.1 centimeters across 230 meters. Proposed method, water channels shallow trenches filled with water, which self-levels, used as a reference. Not definitively confirmed. The 2017 void, unknown. Every time we think we've solved the pyramid, it gives us something new to not understand. So how did they actually move the blocks? In 2014, a team from the University of Amsterdam published a study in Physical Review Letters that answered at least part of the question. They were looking at a painting, a well-known Egyptian tomb painting from around 1,900 BC, roughly 600 years after the pyramid was built. But depicting the same basic technology, shows a large stone statue being pulled on a wooden sledge by workers. In front of the sledge, a figure is pouring liquid onto the ground. Egyptologists had noticed this figure for years. Most assumed he was performing a ritual, pouring an offering. The Amsterdam team ran the physics. Wet sand reduces the friction coefficient of a wooden sledge on sand by roughly 50%. At the right moisture level, not too wet, not too dry, the sand grains clump together, reducing the resistance the sledge encounters. The figure wasn't performing a ritual. He was lubricating a bearing. Try this yourself the next time you're at a beach. Push your hand through dry sand. Feel the resistance, each grain shifting individually. The sand collapsing and refilling around your fingers. The friction constant and high. Now wet the sand until it holds shape when you press it. Push your hand through again. The resistance drops. The grains lock together into something almost solid, almost smooth. The surface your hand moves against has changed entirely. Now scale that up to a 5-ton block on a wooden sledge in the Egyptian desert heat. The calculation works. With wet sand and enough workers, roughly 1 worker per ton, so 10 workers per average block, the pyramid's blocks could be dragged at a pace consistent with 1 block every 2 minutes. For the lower courses, close to the ground. How they got blocks to 40 meters, 60 meters, 100 meters above ground, that's where the debates get heated. stand at the working face of the pyramid at 60 meters high. The wind hits differently up here. In the desert below, there's almost no wind at ground level. The plateau is flat, the air still. At 60 meters, the air moves, warm and constant, carrying fine sand that you feel against your face and hands and in the corners of your eyes. The ground below looks smaller than it did. Not small, just smaller. The quarry to the south, 750 meters away, is visible in its entirety from here. The pale cut stone like a wound in the plateau. You are standing on a ledge roughly 2 meters wide. Behind you, solid stone rising another 80 meters to a point that doesn't exist yet. In front of you, nothing but air and a 60-meter drop. Somehow, workers at this height were still placing blocks, still working with the same precision mortar joints tight, courses level as the workers at the base who could look up and see the ground. How they got the blocks up here is the question nobody has fully answered. The dominant theory for decades, a ramp, a straight external ramp from the quarry up to the working face. The problem, a ramp long enough to reach the upper courses at a workable grade would need to be 1.6 kilometers long and require more material than the pyramid itself. The ramp would be the harder engineering challenge. Alternative, a spiral ramp around the outside of the pyramid as it grew. Less material, but serious corner problems. How do you navigate a loaded sledge around a 90-degree turn with a 10-ton block? In 2007, French architect Jean-Pierre Houdin proposed an answer, an internal spiral ramp. The lower two-thirds built using an external straight ramp, then dismantled as the internal ramp took over. A corkscrewing tunnel inside the pyramid's outer casing, with open notches at each corner for turning. Houdin's theory explains some things external ramp theories don't. It also explains slight notches at each corner of the pyramid's upper section, visible in certain lighting. First noticed by French architect Henri Chevier in 1986, consistent with an internal spiral ramp system. No excavation has confirmed it. Step back down to the ground. Walk away from the pyramid until you can see the whole structure. The sound of it reaches you before you expect it. 20 copper chisels ringing on limestone simultaneously. The sound carrying across the plateau in the still morning air. High and clear and regular like a clock made of stone. Workers calling to each other. The creak of wooden sledges on wet sand. The low grunt of men taking weight. This is what the Giza Plateau sounded like for 20 years. The blocks moved, copper chisels cut them, wooden sledges carried them, wet sand lubricated the path. Organized workers with names and rations and medical care placed them. And at the end of 20 years, 2.3 million blocks sat in precisely the right positions to produce a structure still standing 4,500 years later. The engineering is remarkable. The organization behind it might be more so. Go back to the plateau. Go back to 2,560 BC. You are not an engineer now. You are a stonecutter. Year 15 of construction. You have been here since the project started. You were 22 when you arrived. You are 37 now, and your body knows it. The knees, specifically. 15 years of hauling stone does things to knees. But the pyramid. Stand here and look at it. It is 100 meters high now, 2/3 done. The limestone casing on the lower courses is already in place, white and polished, catching the morning sun with an intensity that makes you squint even from here. On a clear day, the completed sections are visible from miles away. People walk to the plateau just to look at what you're building. You are usually close to the face, 10 meters, close enough to see the mortar joints, close enough to hear the copper chisels ringing on stone 20 times a minute from 100 workers simultaneously. The sound of it fills your ears every day, so constant that you stop hearing it the way you stop hearing your own heartbeat. From here, from this distance, you can finally see the shape. The slope rising at 51 degrees on all four sides. The corners pointing exactly to the four directions your foreman explained this once. How the inspectors check every course before the next one begins, with tools you don't fully understand. The shadow the pyramid throws at this hour, long and absolutely straight, pointing west across the plateau like a finger. You have a son, born 2 years into the project, 13 now, assigned to a supply crew, learning. Sometimes you see him on the ramp not yet cutting stone, but close. You have thought about this on the long days. He will be alive when this is finished. He will stand where you are standing and look at a completed thing, a thing that goes all the way up to a point. He will know your crew's name. It's painted in red pigment on a block at the foundation level, 30 meters below where you're standing right now, in the dark, unread. Friends of Khufu. Your name isn't on the block. The crew's name is. That's enough. You stand there a moment longer than you should. Not because you're tired, not because your knees hurt. Because for the first time in 15 years, standing far enough back to see the whole shape, you understand what you're building, not as a job, not as a series of days, as a thing that will be here long after the last person who remembers your name is gone. The foreman's horn sounds. The morning break is over. You turn back toward the pyramid. The copper chisel is warm in your hand from the sun. You go back to work. The Great Pyramid was finished around 2540 BC. Is less than break time equals 0. 5s is greater than Khufu was buried inside it. His mummy has never been found. The king's chamber was empty when Arab explorers entered in 820 AD. Whether it was looted in antiquity, whether it was moved, whether Khufu was ever actually interred there at all, we don't know. Is less than break time equals 10s. Is greater than the casing stones, that white Tura limestone skin that made it gleam, stayed in place for over 3,000 years. Arab builders dismantled most of them in the 14th century to build mosques and fortifications in Cairo. What you see today, the rough-stepped core, is the skeleton of a building whose skin was taken. The original surface would have been blinding. Standing at Giza in 2560 BC on a clear morning, looking at the finished pyramid, a smooth white triangle rising 146 meters out of the sand, reflecting the Egyptian sun, would have been like looking at a mirror aimed at the sky, visible from the Sinai Peninsula on the right day. We will never see that. It's gone. But the bones are still there. They will outlast everything we are building right now. Here is what I can't stop thinking about. The void they found in 2017, that 30-meter mystery above the Grand Gallery, has been there since the pyramid was built. Visitors have walked beneath it for 4,500 years. Priests prayed beneath it. Arab explorers found the king's chamber beneath it. Archaeologists measured every visible surface around it. Nobody knew. We live in an age where we scan the surface of Mars and the deep ocean floor and the human genome. We have satellites that can read a license plate from space. And there is a room, or something room-shaped, inside the most studied man-made structure in human history, found 8 years ago, and we still don't know what it is. The pyramid is not solved. Here is what stays with me. The next time you are part of something larger than yourself, a company, a project, a team, and you wonder whether your contribution matters if nobody knows your name on the finished thing, remember that stonecutter. His name isn't on the pyramid. His crew's name is on a block 30 meters underground, in the dark, unread for 4,500 years. The pyramid is still there. The next time someone tells you something is impossible, that the math doesn't work, that the timeline is unreasonable, that nobody has done it before, remember that 20,000 people placed 2.3 million blocks in 20 years, using copper tools and wet sand and organized labor, and they got the base level to within 2.1 centimeters. They figured it out. Not all at once, not with a complete plan from the beginning. Block by block, problem by problem, 20 years of showing up every morning and solving the next thing. The next time you feel small in front of something enormous, remember that the Great Pyramid was built one block at a time. One block, every 2 minutes, for 20 years. If this video changed how you think about what humans are capable of, hit that like button and subscribe. Every week, we go inside the structure's history turned into symbols and find out what it actually took to build them. And tell me in the comments what hit you hardest today. Was it the void, a 30-meter mystery inside the most studied building on Earth, found 8 years ago, still unexplained? Was it the workers named crews, good food, healed bones, paid labor, nothing like the slave myth that Herodotus gave us? Was it the wet sand, a figure in a 4,000-year-old painting doing lubrication engineering, confirmed by a 2014 physics paper? Or was it the casing stones, a blinding white pyramid, visible from the Sinai? Gone now, stripped away, only the skeleton left. Tell me. I read every single